Welcome to this short video on CA Test Data Manager. This video is going to concentrate on how CA Test Data Manager manages test data on mainframe ZOS. With fines averaging millions of dollars and prohibitively high infrastructure costs, managing test data on mainframe ZOS is a must. This presentation will set out how the CA Test Data Management solution avoids the dire security and performance implications of moving data to and from ZOS by employing a Windows-based metadata repository and user-friendly GUI to design and maintain test data engineering rules easily while executing those rules using ZOS batch jobs on the mainframe platform. Firstly, let's take a look at test data on ZOS and some of the characteristics that make this particular topic important. ZOS is typically the system of record for organizations that employ ZOS systems as their mainframe source of data. 70% of data still resides here, so it's a very important platform with regard to your system of record data. We also find that many organizations, not only in mainframe but also on distributed, continue to rely on copies of production data for their testing. They simply think that the production data, because it exists in production and currently works, is the nirvana of test data, and that it will prove most of their application testing that they need. The mainframe platform is a secure and reliable platform in production, but if you do copy that production data to your testing environment, what about test? You've spent millions of dollars and time and effort securing that production data simply to copy it into an alternative environment where it's less secure. It has to be less secure by nature, because if it wasn't less secure, the testers and the developers wouldn't be able to perform their job. The other thing is that you potentially don't actually know where sensitive content is, content that could escape through that least secure testing environment, and exactly what that data is and why that data would be sensitive. New legislation such as GDPR needs you to understand where personal information resides, who's using it, who has access to it, and to demonstrate compliance with all of the rules. Some of those rules include breach notification, which would be in the public domain at that point, risking fines, which are substantial, and also risking your reputation. The other aspect of test data for the mainframe platform is the cost of dealing with that test data, that production set of data, and maybe having to move it in order to treat it for PII content to or from the mainframe platform. That is a common activity in some other tooling. The good news is best practice test data management already addresses the impacts of these points, and being able to deal cleanly, easily, and in a structured way to be able to treat and eliminate that personally identifiable information. But first, let's take a look at what is test data management. What do we mean by test data management? There are a lot of different meanings in the marketplace. We believe it's the practice of applying a structured and centralized approach to the management of that test data. That is, being able to control and manage the test data engineering functions that you're going to need in order to deal with PII content, improve your testing practices, reduce cost, and increase efficiency and quality of that test data through a centralized tooling approach. In short, it's about having the right data at the right time in a secure manner that no longer contains personally identifiable information that would break legislation such as GDPR. Typically, we see the practices of centralizing that control, discovering content that you may not fully understand at this point, being able to subset some of that content, being able to mask that content to replace it with alternative realistic content, to be able to synthesize new content, maybe find and reserve the content that's applicable for the testing that you want to perform, and of course to automate all of these processes. CA Test Data Manager has all of these capabilities to enable you to build the appropriate test data management engineering tasks within this one centralized set of tooling. Architecturally, CA Test Data Manager is a Windows platform piece of software or suite of software tools. It is installed on the Windows platform and presented as a graphical user interface. Sitting behind the software itself is a repository. We call it the Agile Data Store or Test Data Repository. This is an Oracle or a SQL Server database specifically written to the needs of the software and persists content from a project and version and metadata set of data. The CA Test Data Manager user will log into the Windows platform typically. This can be linked to Active Directory and LDAP for authentication, but inside the tool there are roles and activities that can be performed with regard to creating test data engineering objects. Also within that Windows platform is a web interface and a web service layer that allows us to communicate out to our own test data on demand portal, other sets of software within the same tooling, and also to external tooling as and when needed. The overall process is first to connect with the source and target databases, no matter which platform they're on. That could be simply flat files within a Windows structure, an I-series DB2400 database, for example, a Z-series DB2, IMS, Adabas or VSAM, Unisys, DMS2, Oracle, SQL Server and so on Linux, Unix, Windows platforms. All of these are just examples of the databases that Windows CA Test Data Manager can connect with, but essentially what we do is connect with them over a standard interface. That would be an ODBC or a JDBC driver with COBOL or JCL functions and PDS libraries on the Z series, Java on Java capable platforms, and on direct databases SQL scripts that we will generate from the tool. None of this connectivity or authentication that takes place on the Windows platform actually replaces any of the host security system for access to that data source. That is still passed using a connector and credentials and permissions appropriate to the kind of activity that the user will perform against those sources. Nothing in CA Test Data Manager will change that particular process. Having connected with the required sources and target data, there is a step process that needs to be taken in order to begin your project and begin your test data engineering operations. The first is to register and to profile the data content that you wish to work with. Now over ODBC and JDBC, this is simply a database connection to the RDBMS. Where we are talking flat files or other systems, other data stores that are not RDBMS, then we will collect that metadata and profile the content of those structures through different means, not through the ODBC JDBC layer, because one doesn't exist. Having registered and profile, we have all of the metadata we need to begin defining the test data engineering operations, and I'll come into each of those operations of subset, mask, synthesize, find and reserve as we go through the rest of this presentation. But essentially all we're doing at this point is defining the rules, the test data engineering rules that we need in order to apply against the database at a later stage, and that stage is at the process runtime. So those rules will later on be externalized as a runtime component relevant to the database platform, the data store where the data is stored. And in particular, for databases such as Oracle, SQL Server and Teradata. They may be database scripts. On Java platforms, they may be Java program executions, and indeed on the Z series, the ZOS platform, it is a COBOL program and a piece of JCL that will run to apply that runtime test data engineering object. And of course, once these objects are created, they are stored and persisted in the CA Test Data Manager repository, the Oracle or SQL Server database supporting the software, and can then be enabled as an on-demand request through our own Test Data On Demand portal, service layer components, and also automated through other automation scripts using our other toolset, Agile Requirements Designer, by automatically generating scripts for you. So as this is focused mostly on mainframe ZOS, let's take a closer look then at the process of being able to manage that data in situ on the mainframe environment. So we can access things such as DB2 ZOS over ODBC. So simply logging into the Windows platform, we will collect metadata from DB2 ZOS over the ODBC connection and store that as a part of our project, as a rule and a metastore inside the repository. Other RDBMS databases also offer ODBC connectivity, and we can perform a similar function to fetch the metadata for those too and store alongside our project inside our repository. However, VSAM, IMS and non-indexed flat files, and possibly some other databases that don't offer an ODBC interface, we can first extract through one of their utilities to a flat file. We collect the metadata for those particular objects, because there is no catalog, through a COBOL copybook or a PL1 copybook that will already access that particular data store and know the structure of the individual field. So having located the copybooks, we FTP those to the Test Data Manager Windows Workbench and perform a parsing operation. We interpret the COBOL code and turn that into metadata that Test Data Manager can store and use as a part of its repository. From then on, we also know the structure of those files now, and we can work with them as if we had found the structure and the field layout, lengths, data types, etc., as we would with any other RDBMS. So exactly the same information we would gather from DB2 ZOS, or perhaps on the distributed Oracle or SQL Server platform. These data objects now look to Test Data Manager the same as any other database. So we can now begin to build our test data engineering tasks using the Test Data Manager Windows Workbench. The metadata stored in the repository, we can go through and build subsetting rules, masking rules, data synthetic rules, and maybe some find and make functions to allow us to identify data that's applicable to our particular test cases that we wish to run. Having defined the rules and created the definition files that allow the batch operations to also be able to interpret the VSAM, IMS or non-indexed flat files, we now FTP those back to a PDS library as JCL and control cards that will be run as a part of a mainframe batch operation. Now these PDS libraries and the base JCL and programs are provided at installation time. Installation is a very straightforward process. We package all of this as a set of XMIT files. So within TSO, you'll simply TSO receive into the high-level qualifier data sets that you need, and you will have a set of sample JCL, control cards, and a load library which will run these batch operations. The sample JCL is typically split into masking jobs that will mask DB2, masking jobs that will apply to flat files, VSAM and extracted IMS content, and also other jobs such as profiling jobs that will fetch metadata and content information that can be stored once FTP'd to the Windows platform in our repository. Now that metadata aren't records, it's not exporting data, it's just a summary, metrics if you like, and meta content regarding the spread of data, the occurrence of data in certain fields, and also classification of whether PII content is been recognized as a part of one of those fields that will indicate to you when building your masking rules on the Windows platform that there's potentially PII data there that needs to be masked. We also have in the delivered JCL library some extract jobs that will extract from DB2, for example, to filter, to subset that content into a precise, concise set of data that is fit for the purpose of your testing. And optionally, you can tie together the two subset and masking processes in one batch operation. So going full cycle then, we extract the metadata, we build the rules on the Windows platform, we send those rules back to the mainframe as a PDS library, and we run a batch operation to create this set of secure masked subset of data ready for you to test with. And the good news is data never has to leave the mainframe. We can take advantage of the performance, the security, the reliability of that mainframe platform and avoid other risks by exporting data off mainframe in order simply to manage it for a test data perspective. Of course, data is never standalone. It has implications across multiple sources within the mainframe and indeed across platforms. So on Z series you may have some databases that are in DB2. You may have some vSAN files that have some related content to your DB2 tables, or even maybe in IMS. They may even be related business logic wise, or even in foreign key perspective, on iSeries, on the distributed platform, maybe in a SQL Server database, or maybe DB2 UDB, the distributed, or some CSVs and file structures. The important thing is that we need to maintain that consistency as we build our test data engineering tasks. So for example, a customer ID. If we have a customer ID in one particular table and it has a foreign key to another table within our DB2 system, obviously we must maintain that key as being the same, otherwise we've broken referential integrity. But it's not only between referential tables. We may also need to maintain those keys between different systems, different databases, and potentially even different platforms. And the way the CA Test Data Manager tooling has been written to retain that structure, retain that context and the referential integrity and the business logic that's needed, but without actually containing the real information anymore that perhaps originated from production. In short, all of the test data engineering tasks that we're going to look at benefit from understanding the metadata, understanding the relationships and the business rules because they're stored as a part of our project in our repository, and all of the tooling allows you to maintain that relationship without actually having to have the foreign keys in the database. And let's face it, if it's a relationship between two disparate data sources, there's unlikely to be any physical foreign key relationship between them. So CA Test Data Manager uses this centralized approach of a test data warehouse or an agile data store. And essentially what we're looking at here is creating reusable assets in our test data warehouse as a part of our project. We've already registered and profiled the data content that we want to work with, so now we want to start building, as a part of our project and our version, some reusable assets, some masking rules, some synthetic rules, etc. This then very much enables a sharing of workload. Currently, your testers probably work in isolation. They are probably working on the same thing but in slightly different ways, storing it in their own personal libraries and never really sharing that content out with anyone else. that in itself is a lot of rework, a lot of wasted effort. So simply by storing things centrally, sharing them and being able to reuse them and inherit them into other test data engineering operations will actually improve the practice of your test data management. Additionally, assets can be upgraded. Because we have a project and a version control within the centralized test data warehouse, we can then upgrade, have different versions of the same metadata, the same data models and the same application, but at different stages throughout our software development life. We can also perhaps start to begin to build regression packs, things that we know we will need over and over and over again every time we make a change to our application. The same standard regression packs can be stored as a part of our project and our version and reused each time we need to initiate one of those regression tests. So that's taken a look at the underlying infrastructure and the benefits of having a centralized piece of software and a repository. Now let's look at each of the individual test data engineering operations that you may need. The first we mentioned is automatically discovering sensitive content or profiling the existing data that you have. Now, built into the tool are some powerful mathematic algorithms that allow you to discover and tag sensitive content. Things like this looks like a name, this looks like an address, it's maybe a social security number, it's a credit card number, etc. They're all built into the tool, and by simply running a batch job on the mainframe to profile the target content, we get a report, CSV file essentially, giving us all of those metrics that we can then FTP to our Windows platform and store within our project as a part of our test data management processes. Once they're in the repository, they're there permanently. They're there ready for you to use as you go on to build other test data engineering operations. So profiling is a very important first step, enabling you to understand the content in much more detail, and potentially where you don't know there is already sensitive content, it will identify for you the files, the tables and the fields that potentially contain PII data. And of course this doesn't only happen on mainframe data objects, this happens for every major database type, flat files, etc., and can be stored across platforms in the single project as a single version within the CA Test Data Management warehouse. Perhaps the next step you would like to take is actually to reduce the amount of content that you take from production. We call that subsetting, being able to take a slice of referentially intact sets of data. Now there's two ways of approaching this. One is arbitrarily, give me the first 1,000 rows, give me 10% of every 10,000 records, give me a record, and we end up with a very small set of data that is fairly random. There's no particular set of attributes that are known within that set of data. It's just counting rows or counting percentages. Our preferred approach is to be able to identify the attributes of data that you need and to extract just those. Maybe you're doing a test for people who have a specific kind of credit card, or somebody who has made 10 orders in the last year, or who has 15 different types of your products. All of these attributes, all of these conditions can be coded into the CA Test Data Manager UI and selectively extract content from a set of production copy data. So in this particular diagram, the colored blocks typically represent different values, different attributes that you need for this particular test that you're about to execute in your testing environment. So we're already being a lot more precise about the content that we take from production and put into test, thereby reducing our risk and exposure to loss of data from that environment. But even reducing the amount of data that you have in production won't satisfy legislation such as GDPR and reputation should that data escape or breach from your testing environment. So we recommend, whenever copying, whether subsetting or full copies of production, that content is masked. And the Test Data Manager Fast Data Masker routine can mask millions of rows in minutes by running over 80 built-in data masking functions against that data, with the aim of replacing that PII content, the personally identified content, with other realistic, referentially intact content. And that can be done consistently across different databases on the mainframe, and indeed across different platforms where your applications link to other applications maybe not running on. The design process is simply on a table or a file basis, on a field by field basis, where you can filter the fields based on the profiling that we did before, that will tell you whether it thinks there's a name or an address or a phone number, and how to apply an appropriate masking rule to that type of content. And as you work through each of the data objects that you wish to treat, building up these file, table, field, function masking rules, you end up building quite a comprehensive set of rules that you will then apply against all of your data, the mainframe and the distributed, so that it maintains consistency. At the same time, the tool will produce audit reports so that you can demonstrate compliance with any of the legislations such as GDPR, GLBA, HIPAA, and PCI. Those audit reports can contain a level of detail, such as before and after values, but obviously that in itself would reveal some sensitive content, so that particular report can be password protected by your own host security system, but if you're producing it, then do ensure that you maintain that level of consistency, that level of security. But some of our customers don't actually trust themselves or any tooling to mask all of the sensitive content and absolutely fully comply with GDPR. There is potential, no matter how small, for you to, and the tooling, to perhaps not identify a particular piece of PII that could personally identify an individual. Now, it's unlikely that that's going to happen, because with changing all of the other, masking all of the other fields around it, one piece of information may not actually lead you to the conclusion that it's an individual, particularly without any external content. And that's part of the GDPR rules, that there has to be some way of identifying the person without having any external information, and that audit report would typically be an external piece of information that they should not have access to. So perhaps it will still comply even if you didn't mask every single field or identify every single field of PII. But where you don't want to take the risk, CA Test Data Manager also has synthetic data generation processes. And those processes include extensive algorithms for synthesizing new data content. So there's absolutely no risk of any personally identifiable information remaining there, because it's all synthesized, it's all fictitious. And you apply these algorithms in a kind of data painter style. Now, it's hard to see maybe on the video, but these functions here are the built-in algorithms, and you can combine these algorithms in each field, in each table. So we have debit cards, we have people, and the various fields, and we're painting the type of data that we want to appear in each of the rows that get published during this synthetic data process. Now, this looks nothing like real data at this point, because it doesn't get to be real data until we actually publish it. It's our term for injecting or loading the data into our target databases or file objects. What actually happens is that all of these algorithms resolve at publish time, so that even one row in our synthetic data generation object resolves to maybe many rows, however many rows you need, 1,000, 100,000, few 100,000 rows that are injected as a part of your need for test data into the test data environment. And these are reusable. So once you have this model, you could say, give me another 10,000 customers that have these kind of attributes. And the attributes themselves, if you use symbolic values, can be substituted at the time they are published, at the time they're injected. So for example, I need another 100 customers with an American Express credit card associated in my system. That characteristic, that attribute of being an American Express credit card, can be injected and substituted at the time it's published to the data target. The other aspect is that once we have this stored as a test data engineering operation in our test data warehouse as a part of our project, we also now have version control. There's also inheritance within the test data warehouse. So for example, if I wanted to create different types of customers, a basic customer, a customer that's made several bookings with us, a VIP customer that has certain flags and certain information against them, I don't have to go and create that customer object all over again. I can inherit from my basic customer through to my regular customer through to my VIP customer. And the benefit there is reasonably obvious, because I don't have to recreate it again. I already have a customer object. But the other joy there is that if my basic customer ever changed, that change will cascade up through all of the other objects I've inherited from it, so that again, I don't need to maintain several different versions of my customer object. It's all done from the inheritance of the basic one. And as mentioned earlier about version control, there may be different versions of your data model, of your application, in operation at any one time, different stages of your software development lifecycle. So you need to be able to work with these objects in different ways. You know, you're going to have a version 1 that's active and you want to publish into one environment. You're going to have a version 2 with different metadata that you're going to need to publish into a different test environment. So at each of those version stages, you don't have to recreate the objects, you simply upgrade them to the metadata that's contained within the different versions, and thereby saving again a lot of rework and a lot of potential for error. Now, with regard to synthetic data generation for mainframe objects, obviously the objects that have an ODBC JDBC connector for us, we can simply inject that data directly into that database target. We have a connection. Where we have to have file objects, potentially maybe a VSAM file for example, we know we understand the metadata and how to create these synthetic data objects, because that was found during our registration and profiling by capturing the copybook. But if we're generating data as a file on the Windows platform, we have a couple of things that we need to deal with. ASCII to EBCDIC conversion, for example, and also the Windows platform doesn't understand anything about packed decimal or signed decimal and all of those kind of things. So as the copybook is parsed and turned into objects that Test Data Manager understands, we expand and put a marker against those to say, well, actually, this is how it's represented in Windows. When it's going back to the mainframe, this is how it needs to look. And that's exactly what we do. So once we've generated a file on Windows, to get it back onto the mainframe before we FTP it, we go through a file conversion process that does all of the conversion between ASCII and EBCDIC, and also manages the difference between non-packed to packed decimal, etc. in your native VSAM file type. So once that object is converted and FTP'd, it's then available on your mainframe system for use. That may require it to be reproed into the actual target through another batch process, because potentially this data could be online somewhere in Kix or something like that. So there may be additional steps to take, but essentially what we're looking at is an FTP of the base data in mainframe format that you can then just drop into the testing environment in the right place for you to use it. Of course, it's great that we have the capability to build all of these test data engineering tasks that run on mainframe and treat our data on the platform where it resides, but Also, as a part of Test Data Manager, we have a way of organizing that data. Because even with the existing processes you have, I wouldn't mind betting that you have some problems with sharing data. People using sets of data that they shouldn't be using. Different tests unwittingly, unknowingly overwriting data that somebody else is going to test with. So as a part of the overall Test Data Manager process, we also have a test matching capability. So with all this good set of data that you've now generated, you can distribute, share, find and reserve that content amongst all of the testing that you're going to perform. Now, to do that, the first thing we have to do is to gather the attributes and the test cases together. So you're going to run these 3,000 test cases, each test case needing a different kind of data, different condition of data per customer, per account, however, whichever way you need it. And we need to gather that and store that as a part of our project. Also, once we've identified those attributes, we need to locate where in our data estate, across potentially multiple databases, multiple platforms, where those attributes reside so that we can check on them, validate them, verify they exist, and bring the keys of that system into what we call a test mart. Now, that test mart isn't whole records, isn't whole applications. It's simply keys and attributes that the test cases are going to need in order to run the tests, and we gather those and store them in one centralized place so that we can match each test against an attribute and provide the keys that match that particular test, and perhaps feed those on through automation scripts such as QTP or Rally or other tool sets that can automate the test operation. On the mainframe, we run a batch job to do that, to gather the attributes from the mainframe data sources. We don't export any data wholesale from the mainframe. We just gather these little records, little keys, and put them into a CSV file. And that CSV file is uploaded to the test data management platform, and then those attributes loaded and stored inside the separate test data mart, where we will do our comparisons and matches. So the benefit here is that now we have a good set of data, we can now divide that data into specific test cases so that when our test system runs, we're not actually tripping over each other and burning data from one test that another test is going to need later on. Of course, it is rare for these steps to run in isolation. We're not just going to subset data, we're not just going to mask data, we're not just going to perform a find and reserve on data. We need to combine these operations together. We'll likely need to combine these operations across different data stores and across different platforms. And one of the best practice approaches to do that is something we call a gold copy. Now, right back at the beginning, we said it's common for organizations to continue to copy data from production simply because that's what they've done for a long time, and they think it's the easiest way of obtaining, provisioning test data in their testing environment. And to a certain extent, that's fine. Let's allow them to do that. But before they do copy data down into their testing environments, perhaps we need to have a process before then that has pre-treated this content, that it has taken a subset from our production source, maybe an arbitrary one, maybe an intelligent covered subset. The content must be masked if we're going to make that copy from production to satisfy GDPR rules and other legislation. And what we're suggesting is that if you're going to do those two processes, allow that to create you a gold copy of subsetted masked content that you can then go back to your business as usual process and copy as many times as you like into those different testing and development environments. You can also have in the test data warehouse the synthetic content if you wish to add additional content. So for example, data that has been cleansed from the production environment for previous errors in production. That's not going to appear there anymore. So how can you re-inject that data so that you can be sure it doesn't reappear the next time that application changes again? Well, that can be the synthetic content injected into your gold copy, ready to be dropped into any of your number of testing environments for your testing purpose. There may be synthetic content that doesn't already exist in production, simply because of the way the nature of the application development that's taking place. It's a brand new system, or it's a brand new database. How are you going to synthesize that content? Again, you can copy down from production what you do have and then synthesize content directly into your testing environment that you need for that particular part of your software development lifecycle. Even to the point perhaps that from that golden copy you could begin your find and reserve process, so that you understand the test cases that you're going to run in test development environment number 1. You've catalogued those test cases, you've catalogued the attributes, and you've built a test mart from that gold copy. You now have a good picture of which test cases have data and which test cases don't, so you could make some new data where needed, or you could even drive the subset from the gold copy into your test development environment number 1, so that you only have the precise set of data that you need to test with for that particular test cycle. So in combination, all of these test data engineering operations we've discussed can be combined together to create an overall enterprise test data management strategy that is fit for purpose and provides you with the right data at the right time, while managing all of the security, all of the performance needed without bringing data in and out of the mainframe, and all of the PII compliance that you need. So to summarize, to avoid costly mistakes when managing ZOS test data, avoid the use of raw production data. It's mandatory now. Legislation is coming into place that will significantly increase the fines. Previously, other legislation, the average cost per incident of data breach worldwide has been in the region of 3.5 million. In the US, the risk was higher at 5.85 million. As discovered and documented by Ponemon Institute in 2014. And in as many as up nearly 60%, 59% of these incidences, the risk could have been mitigated by implementing test data management best practices. And CA Test Data Manager allows users to apply test data management practices across many different platforms, and including directly on the mainframe, reducing the reliance on slow, expensive extract, transform and reload technologies just to ensure compliance, and also taking advantage of fit for purpose test data, improving your test data management practices across the board. So managing test data on the mainframe platform directly allows you to provision millions of rows of high quality, meaningful, referentially intact data in a very short period of time, and at less risk to the quality and compliance of GDPR. Thank you for listening to this video, and I hope you will reference some of our other videos on CA Test Data Manager as you need.